All right, this one, as it turns out, is going to be a little bit of work. Well, actually a lot of work. We have two different random variables. We have a random variable x that is binomial with parameter p, where p is unknown, and that is the number of components for the 5-component system that work. And then we have a second random variable y, which is binomial with parameters 3 and p. So there are 3 independent components. Each works with probability p. So find the values of p for which a 5-component system is more likely to work than a 3-component system. And the system works if at least 1/2 of the components work. So the 5-component system will work if at least half of the 5 components work, and so that's the probability that x is greater than or equal to 3. Okay? And the chance that at least half of the components over here works, well, that would be the chance that y is greater than or equal to 1.5, and 1.5 can't happen, so the chance that y is greater than or equal to 2. So we're going to be looking for this inequality. Find a condition on p so that the probability that x is greater than or equal to 3 is greater than the probability that y is greater than or equal to 2. All right, here we go. The chance that x is greater than or equal to 3. Well, the chance that x equals 3 is 5 choose 3, p to the third, 1 minus p to the second. The chance that x is equal to 4 is 5 choose 4, p to the fourth, 1 minus p to the first. And the chance that x is equal to 5 would be 5 choose 5, p to the fifth, 1 minus p to the 0. So these 3 terms added together is the probability that x is at least equal to 3. That it's equal to 3, or it's equal to 4, or it's equal to 5. So that's the left-hand side. We want the left-hand side to be greater than the chance that y is greater than or equal to 2. Well, that's going to be 3 choose 2, p to the second times 1 minus p to the first. That's the chance that y equals 2. And the chance that y equals 3 would be 3 choose 3, p to the third times 1 minus p to the 0. And so now we have this nasty inequality in p, and we have to try to simplify this thing somehow. All right, well, let's start simplifying and hoping for the best. 10p to the third, 1 minus p squared, plus 5p to the fourth times 1 minus p. And then this last term here is p to the fifth. We want that to be greater than or equal to, 3 choose 2 is 3, p squared times 1 minus p. And then this last part is p to the third. Okay, so let's get everything over to one side and hope for the best. So let's see. So let's subtract. So if we have greater than 0, so this term is all by itself, 10p to the third times 1 minus p squared. Now these two terms I'm going to combine because they have a 1 minus p term, and that's a common. So that's, I'll just kind of list those next to each other. So plus 5p to the fourth, 1 minus p, minus 3p squared, 1 minus p. And then I'll put these two terms next to each other, plus p to the fifth, minus p to the third. Okay, now what can I do to simplify this? Here I have 10p to the third, 1 minus p squared, plus, okay, these I'll just kind of copy, 5p to the fourth, 1 minus p, minus 3p squared, 1 minus p. Now I can factor this. I can factor out p to the third, and that leaves me p squared minus 1, less than 0. And p squared minus 1, so let me copy one more line. 10p to the third, 1 minus p squared, plus 5p to the fourth, 1 minus p, minus 3p squared, 1 minus p, plus p cubed. Then I have p plus 1 times p minus 1. Now p minus 1 is the negative of 1 minus p, so I'm going to put a minus sign here, and I'll write 1 minus p here instead of p minus 1 because I'm going to be factoring out on my next step. So ordinarily you'd write plus p minus 1. I'm going to put a minus here and a 1 minus p here on purpose because on my next step I'm going to factor out a bunch of stuff. P squared comes out of all terms. Also 1 minus p comes out of all terms. What's left is going to be, out of this part I have 10 times p times 1 minus p. Out of this part I have plus 5p squared. Out of this part all that's left is the minus 3. And then on this last part all that's left is minus p times p plus 1. And I want that to be greater than 0. Alright, let's see. Well, p squared is positive, 1 minus p is positive. I can divide by a positive number, and the crocodile doesn't change directions. So if I divide by this positive number, the greater than sign stays put. So let's multiply out what's inside here. I have 10 times p minus 10p squared plus 5p squared minus 3. Then I have minus p squared plus p to be greater than 0. And so let's collect terms. We have minus 10p squared plus 5p squared minus p squared. So that's minus 6p squared. Then I have 10p and this should have been a minus here, I apologize. 10p minus p gives me minus 9p. And then lastly, I've got the minus 3 here. So, sorry, plus there. Then minus 3 greater than 0. So let me say that over again. Minus 10p squared plus p squared minus p squared is minus 6p squared. 10p minus p is plus 9p. And then I have the minus 3 carries down. Okay, I can factor out negative 3 out of this, and that leaves me with 2p squared minus 3p plus 1 greater than 0. And that factors as minus 3. Then I'm left with 2p minus 1 times p minus 1 needs to be greater than 0. Or let's put it like this. If I bring this minus sign inside here, I have 3 times 2p minus 1 times 1 minus p is greater than 0. Now once again, 3 is positive, also 1 minus p is positive, and so this simply becomes 2p minus 1 has to be greater than 0, so that p has to be greater than 1/2. So the ultimate upshot is that for this nasty left-hand side to be greater than this right-hand side, then what has to happen is that p has to be greater than 1/2. Now that makes sense, right? If I want at least half of the trials to be successes, and if p is more than 1/2, then it stands to reason I want to have more successes than as opposed to less successes. If p is bigger than 1/2, then I would expect that the chance of having more than half of them be successful would be bigger than if I only had 3 attempts. So, as I said, this was a long problem. I included this problem in the review mostly to remind everybody about the formula for the binomial distribution, as well as just a little bit of algebra practice.